Good evening to everyone. So first of all, I welcome you all for our online lecture series on research scope in emergency area of civil engineering. So today is the second day for our lecture series organized by Aditya Learning Academy in association with Department of Civil Engineering. And today I go to deliver the lecture of current research and application of fiber reinforced concrete composite material. Before I go to start with the title, and I introduce myself. Myself, Dr. S. Govindarajan, Department of Civil Engineering, Aditya University. So I have 16 years of experience in teaching and 4 years working in industry also, and 6 years I worked in that Ethiopia. And I completed my doctorate in Anna University, Chennai. So in my PhD title also, performance evaluation of certain non-metallic fiber-based concrete. That's the purpose I go to deliver today lecture series in the title for that fiber reinforced concrete only. So before I go to start further my seminar, these are the contents I go to present today for the FRC fiber reinforced concrete. What are the history, how it will be formed, and what is the necessity of fiber reinforced concrete, and what are the various types of fibers are available, and what are the mechanical properties of fiber reinforced concrete, and what are the factors are affecting the fiber reinforced concrete, and what are the various advantages of fiber reinforced concrete, and also I given some of the case study. Right, so how it will be using for that some practical oriented experimental related program also, and after that I given from that application of FRC. Finally, I given as the literature survey based upon the fiber reinforced concrete, what some of the literature they are done in the fiber reinforced concrete related work. So here why I given as a literature survey in the last part, because first of all we must be know what is the fiber reinforced and what is the application, what are the advantages. Then only if I go from that literature review, then easily everyone must be understood. That purpose only I given as the literature survey in the last slide. Okay. So now I move on to that my main topic area for fiber reinforced concrete. So actually that fiber reinforced concrete is nothing but when the concrete is mixing of cement, fine aggregate and coarse aggregate and add some little amount of water, and apart from that I got to add for that fiber material, that is for discontinuous, uniformly dispersed or discrete fiber. That time is called for the fiber reinforced concrete. So what is that use of that fiber reinforced concrete? Normally for the concrete, it is brittle in nature, right? So I want to improve from that for our concrete. Normally the concrete having weak in tension side and strong in compression side. Okay, so my aim, I want to improve the strength in tension side. For tension side only, I got adapted for that fiber. So that is the purpose, that is called for that fiber reinforced concrete. And what are the various properties of fiber reinforced concrete? Here I given some of the 6 components I given for the durability and crack resistance and tensile strength and impact resistance and energy absorption also. Here the first time for the durability is nothing but it is given that from that long life. Okay, so once that fiber reinforced concrete is involved in our concrete means it give the long life. Why? Because of your concrete, suppose the normal concrete without fiber, what happen? If the load will be acting, the concrete will get that easily failure, right? So to avoid that failure, the crack will be formed. To avoid that crack also, I got to introduce for this fiber. So once the fiber is introduced in the concrete, it will be arrest in the gap. Okay, in the concrete they having some gap is there. So this fiber will be arrest all the gap. So that load carrying capacity it will be improved. That purpose only the main part of the properties I given as the durability condition also. And second one, the crack resistance. Okay, and the crack resistance is nothing but they having for if the load will be acting in the structure, the crack will be formed, right? All the type of the structure, when that load will be acting, surely the crack will be formed. So our aim to avoid the crack, therefore that fiber will be used. right? This is the second property. And third one is the tensile strength. Okay, so when the structure they having for the compression as well from the tension side, so you want to improve for the tensile zone only, then only the structure will be within the stand, right? That purpose they having for fiber reinforced will be mainly used in the properties. And another one is from that impact resistance. So what are the various loading for impact resistance they having for the shock and blast also, and suddenly applied load. So this will also that is affected by our building structure. So to avoid that sudden impact load, this fiber reinforced concrete should be avoided. Okay, and the last one for that, absorb energy also, that is called for that energy absorption. So these are that all 6 parameter is main role playing for that fiber reinforced concrete. So before we go to starting from this one, this all 6 properties is known, then we move on to that main area of the fiber reinforced concrete. And what is the history? So how this fiber reinforced concrete will be developed? This is not as a new, actually in ancient period also this fiber reinforced concrete also it will be involved, right? So here one type of the natural fiber is there, that is for the horsehair. Horsehair also it is used for the mortar. When we were using from that construction for the mortar, they are using as a horsehair also. And another one is from the mud bricks. Okay, in that mud bricks also they are using the straw, that is also the natural one. And after in the 1900 years they are using from the asbestos fibers also. And 1950 the composite materials, that composite material is nothing but if the material they having from more than 2, right? If 2 or more than 2, then the structure is called as composite material. So it is also applied from the 1950. And the last 30 to 40 years, that synthetic and artificial fibers are main role in that concrete structure. So now many researchers they are doing project and research work in that area of the fiber reinforced concrete, and they will be find out that various type of the fiber and what are the mechanical properties of each and every fiber. We will see one by one in the later. And here, what is the necessity of fiber reinforced concrete? Already I informed that first slide, the properties. The same way you go from the necessity, right? For improve the durability conditions, that fiber reinforced concrete will be used. At the same time for impact resistant, for suddenly applied load. If you want to increase from that load, so you go to increase your impact resistance will be acting. And next one is for that shrinkage, right? It will be for when fiber is used in the concrete, it will be reduce the shrinkage, not only from that, only from the drying shrinkage. This will be also reduce that plastic shrinkage also, right? And next one is that water leakage, mainly from some of the structure for from sewerage treatment process and from any water tank related project. So that area also, that fiber reinforced concrete will be role in the main play. That is for reduce all the permeability, that permeability related to all water related project only. So that fiber is also used for your permeability condition. And this is a very important graph for the stress strain curve. Here normally for normal concrete, so what is the stress strain curve? So in the normal concrete, what happened, your stress strain curve, that linear up to that elastic limit only. The linear will be taken from up to the elastic limit. That value will be taken for the strain 0.002, right? After that, the load will be applied, the material will be go for my ultimate load, and finally it will be go for the breaking. But when fiber reinforced concrete will be added, so what happen is, up to that extent, for this is not for that linear, non-linear. For when fiber will be acted, the graph will be come for non-linear structure. So not only it will be stopped from the 0.002, it will be moving on up to 0.003 to 0.005 also. When fiber will be added, that strain value will be move on to 0.005 also. So that is the main for stress strain curve in the fiber reinforced concrete. And this is for that some practical diagram how the fiber will be added into the structure, right? The first one, for without fiber, when the heavier load will be acting, some easily it will be go for the break, because of there is no any joint between that aggregate, right? Because in that all the aggregate some gap will be there. without any adding of any fiber material, when the load will be acting, surely the material will be go for the breaking. So to avoid that one, I go to introduce from the fiber, any one type of the fiber. So the fiber will be included in that all the gap. It will be filled for all the gap. So what happened? It will be closed for that your crack pattern. When the load will be acting, just with fiber material, it is not easily go for the failure. Why? Because of we are arrested the gap, all the gap by using the fiber materials. Okay, so this is for the two diagram for the comparison of without fibers and with fibers of the material. And here what are the various type of the fiber? Normally there are two type of the fibers is available for natural fiber and artificial fiber. So what is the natural fiber? So the natural fiber, for many type of fibers is available, like jute, flax, canaf, hemp, sisal, coir, banana, pineapple and lotus. These are all are natural product only. It is called for natural fiber. It is also will be used in the concrete in the mixing, right? But the thing is, when we would add for that natural fiber, the strength is it give for more than the normal concrete, but it is not more than from we are expecting some value, like building structure. It is not possible we go to do for this one, because it is will be improved, but one certain limit only. But when we go for another one type of the fiber, for artificial fiber, this type of the fiber only mainly used for all the type of the construction site, right? Because of that artificial, they having for different type is there: glass fiber reinforced polymer, carbon fiber reinforced polymer, and alkali fiber reinforced polymer, and basalt fiber reinforced polymer. And these are all that will be making us a reinforcement, right? In that artificial fiber, that is a man-made fiber. We have to taken that material from manufacturing from the company. What requirement if you need it for regular shape and size, you have to get from this type of that reinforcement later also, as well as for mat size also. Not only for the reinforcement, for the mat size also we go to using in the construction site. So what happens is, for this one, for the reinforcement, suppose you are using from our normal building, we are using some 12 mm size of rod and 8 mm for stirrups we are using. So this will be for resist some certain load only. But when we go from that artificial fiber reinforcement, surely it will given for the more strength. It is not easily breakable. Why? Because of the tensile strength value is more than the normal concrete, for the normal steel value also. So we got using for the reinforcement. This type of that, for mat type of the fiber, it will be mainly used from external strengthening of structure. Suppose already one structure is there, when the load will be applied, the material will be failure. So now I go to rehabilitation. I go to again reuse that structure. So what I go to do, I want to make it as for external strengthening of the material. That time I will using for this type of the mat type of the fiber. And here for that the short period only, that's what I showed some of that fiber, what are the properties and where it is used. I will show you. The first one is from the steel fiber. Normally the diameter will be varying from 0.25 to 0.75 mm, the diameter of the fiber. Another one is from this, where it will be mainly used for flexural strength and impact, as well as for the fatigue strength also. So these all the strength already I told for the properties of fiber reinforced concrete. Surely it will be improved for the strength of the structure, right? And where it is used, this type of that steel fiber mainly used from the road pavement structure, right? In the road pavement also they will be used. At the same time the bridges deck, because of in the bridge structure the load that will be taken from the moving vehicle, right? So at the time the heavy load will be passing through the deck. So in the deck also they will be using for the steel fiber. When the deck will be construction, at that time the steel fiber that will be inserted in the concrete, the mixing of concrete, right? And another one important also, the thin shell as well as the plates structure, at the time also that this type of the steel structure for the steel fiber will be used. And another one is for carbon fiber. Here I said in the last two slides before, I said different type of the artificial fiber. glass fiber, aramid fiber, basalt fiber, and steel fiber, right? Compare this all, which one is that maximum load carrying fiber? This carbon fiber is that maximum loading carrying for the fiber, but the thing is that cost will be very higher compared with the normal fiber as well as the artificial fiber. For other than the carbon fiber, that cost will be very high for the carbon fiber, but the thing is the strength is, it will give more, right? For 4000, for the tensile strength it will be given for 4000 Newton per mm square. And where it is used for in the structure, mainly from the cladding of the your building structure, like wall. In that wall also, outside cladding is there, roof that the cladding is there, in that place they will be using for the carbon fiber, and panel members and the shell structure. For this all the three type of the structure, only for the main structure only I said, but for what are the various structure is available, you would using for this carbon fiber, right? And another one is from the glass fiber. Here in the diagram I will show from the two type of that glass fiber is there. One is from the strand type, another one is from that your wrapping, right? For mat type. So here for the first one is from the strand one, it will be mainly used for your internal strengthening. Whenever that concrete will be making for you would mixing of all the materials, so cement, fine, coarse aggregate, at that time you go to placing of some amount of percentage, right? Some amount of percentage fiber it will be added into the concrete. And next one from the mat size. So here I will show from only one diagram for the glass fiber, but here that mat for the glass fiber there are two types. So one is from E glass, another one is from X glass, right? The E glass for mat fiber, that is nothing but electrical grade glass fiber, and S glass is nothing but that is for the structural or strength glass fiber, right? These are the two type of the fiber they will be used for that mat format. Where it is used for this mat fiber, mainly from that outside of the structure. Suppose if the structure they having from the beam structure, what we have to do, how I go to make it from that fiber? If that beam for bottom side and two side for the front and back side, only you go to wrapping for this material. Why we don't go for the top side of the fiber? Because of it will be for beam, it will be attached in the slab, so it is not possible. Only U shape only wrapping will be possible, right? So that type of the fiber will be called for electrical grade glass fiber or S glass grade fiber. And the strength it will be compared with the carbon fiber. This one for little minimum for compared with the carbon fiber, like tensile strength having for 3000 Newton per mm square. And here for in this tabular column you must be easily understand for various type of the fiber. Here I included from all type of the fiber, natural fiber, synthetic fiber and artificial fiber, everything I will mention from here: aramid, carbon, E glass, S glass fiber, polyester, polytoluene and cotton, coir, flax. And see, these all are first four, it will become from artificial fiber, and polyester and polyhydroxylate, this all will become from your synthetic fiber. Remaining all it will becomes under from natural fiber. So what are the parameter they are testing? All this value will get from that experimental test result value only, right? The first one is from the density, second one from elongation, and third one is from the Young's modulus value, and last one is for the tensile strength, right? So these all the value they are going to conduct in the experimental value. Here you must be just to check from this one. For glass fiber and carbon fiber only main play role will be acting in the concrete. These two only given for more than the 2000 3000 value compared with the other fiber material, right? And the third one will become for that aramid fiber also. So this one also that will be nearly from our carbon and glass fiber. Now recently our researchers they are doing for various artificial fiber, like other than for this one from basalt fiber is there, then AR glass fiber, alkali resistant glass fiber, where it is used for alkali resistant glass fiber when the structure is constructed near in the sea, in the near sea place. At the time they will be using for alkali resistant glass fiber, because if the site will be near in the sea, what happened? Corrosion will be formed, right? So to avoid that the corrosion, we go to using for alkali resistant fiber reinforced rod they will be used. Otherwise, they will be using for the coating material. For the coating material, they will apply from the reinforcement. So it will be avoided for the corrosion. So that type they will using for alkali resistant glass fiber. And based on that mechanical property, here I want to discuss with some of the parameter like modulus of elasticity. When you go to add 1% of fiber content, it will give for modulus of elasticity value increase 3%. Just you think as if you add for 1%, just 1% of fiber will be added into the concrete, what value you will get from the Young's modulus value, that is the 3% value that will be given more, right? At the same time, for the flexural strength, when fiber reinforced you are using, that value will be increased for 2.5 to 4% value, right? At the same time, for split tensile strength, the split tensile strength, it is nothing but that is for the cylinder type, right? That experiment they are using for cylinder type. So when that fiber will be add for 3% of fiber into the cylinder, that is a concrete, how much value it will given? For 2.5 times of normal concrete strength. You go to multiply by normal concrete strength value, multiply by the 2.5, you will get that value, right? And the toughness for how much load that will be for resist, the toughness also 10 to 45 times that of plain concrete, right? And the last one for already I said from that impact resistance. For impact is nothing but from suddenly applied from the shock and the blast also. At the time they having for that value, when fiber will be added, that value will be given as 5 to 10% of compared with the plain concrete. So these are all where I get from this all the 5 type of the parameter. Based on this, that experimental result value only, right? And next one, these are all another one important things for what are the factors are affecting FRC. Here I will show some 4 types of factors are affecting for fiber reinforced concrete. First one is from volume of fiber, second one is from aspect ratio, and third one is from orientation of fiber, and the fourth one is for relative fiber matrix stiffness. These 4 only mainly affected for our fiber reinforced concrete. Now I explain for what are the criteria that 4 for one by one. The first one is that volume of fiber. When there are when you go from the volume of fiber, they having for the 3 type. What is from low volume fraction, another one is from moderate volume fraction, and another one is from high volume fraction. And where it will be used, suppose your low volume fraction, that value will be less than 1%, and in which place this type of that if this type of the concrete will be used only for the slab and pavement, right? In that 2 place only we go to using for low volume fraction, because of that volume fraction will be less than 1% of fiber is enough for your control of your loading condition, right? When you come from the moderate volume fraction, your value will be 1 to 2%, like that is not used from that your all the type of structure like that. Wherever the construction for repairing work, wherever the repairing work is there, by given for one example for shotcrete, right? In that place you go to using from moderate volume fraction like 1 to 2% of fibers only. Now I move on to the third one. For high volume fraction, that value will be for greater than 2%. So your value will be more than for 2%, mean surely this type of the fiber will role play in high performance concrete. Okay, normal concrete is there, then high performance concrete is there, and the third one now it will become for ultra high performance concrete also it is available, right? So in that type of for ultra high performance and high performance concrete, this third one will be acting for high volume fraction, because that value will be for greater than 2%. And this is the main thing for aspect ratio. This is the main role for the fiber reinforced concrete. Before you go to select for any type of the fiber, you must be know how to select for that aspect ratio. So what is the meaning of aspect ratio? That is the ratio of length to diameter, right? The length of the fiber to diameter of the fiber, that is called as the aspect ratio. So here normally we are as per the research only I said that aspect ratio value will be starting from 30% to maximum that value will be taken from 150, right? That minimum value will be taken from 30 and maximum it will be go up to 150. This is the range you go to select for that aspect ratio. What are the fibers you are using, but you are selecting for 30 to 150 only for aspect ratio. Here I given some tabular column, types of concrete and aspect ratio, and what relative strength you will get, and at the same time for relative toughness also you will get. Okay, when I go to add for the fiber into the concrete with a different aspect ratio, suppose when I add more number of fiber for some will taken from aspect ratio 0, 25, 50, 75 and 100. So what we get when the 0, surely some percentage from the strength value is there, like 1 it will given for relative strength, at the same time for relative toughness also that value given as the 1. When we move on to the 25, your aspect ratio selection is 25, what is the relative strength value? It will be move on to some more strength value compared with 0 conventional. Therefore 1.5 and relative toughness it will given as the 2. And again I go to taken from that more than for 25, like a 50, that value will be for little increase, like relative strength value is 1.6 and relative toughness also 8 value. When I go for the third, for the fourth one 75 aspect ratio, the relative strength is 1.7 and relative toughness equal to 10.50. Now you see the last one, again I go to select for more than 75. So what happened? Your values will be not increase, that value will be go for decrease, right? If that value will be taken more and more, the strength is surely is not given. In certain period, that strength value will be go for decrease, where it will be happen in between 75, your aspect ratio selection is 75 to 100, surely that value will be go for decrease, 1.7 to 1.5 for relative strength, and relative toughness also 10.5 to 8.0, that value also they will go for the decrease. Therefore the selection of aspect ratio is main important for any project for using fiber, right? So again I will inform, for aspect ratio is nothing but the ratio of length of the fiber to diameter of the fiber. And this one for the third one also, orientation of fiber. Here I given for 3 type of the orientation, whether the fiber will be for placing in the parallel to the load. The first condition is given as for your fiber will be placed along in the where the load will be acting, at the same direction your fiber will be placed. And another one, the fiber will be placed from perpendicular to the where the load will be acting. That is the second case. And the third one is for randomly distribution of fiber. Randomly distribution means the fiber in place of either horizontal or vertical or inclined, what are the positions is there. So that is called for the randomly distribution of fiber. Here, in which one is suitable for that orientation of fiber, which one is the correct one? According to the 3, which one is the correct one? When we would taken for that all the 3, the first one, the parallel to the direction of load. Why? Here I go to placing from your fiber I got placing from the horizontal where the load will be acting in the horizontal direction. So what happen is that your bonding will be in that good condition because of concrete as well as from the matrix. For concrete matrix as well as for the fiber, both it will be in the strong, right? It is for the good bonding between these two. It is not go for the debonding or it is not go for the slippage. It is not possible. When the fiber will be placed along in the loading condition for horizontal. Suppose that fiber will be placed along in that vertical. So what happen is your debonding failure that will be surely that will be occur. Or what happen? It will be slippage will be formed when the load will be acting for horizontal, but your fiber will be in the vertical. Third one is for the randomly. The randomly it is not wherever you go to placing of that fiber in different position other than the horizontal. So surely that structure will be go for easily failure. So the orientation of fiber also mainly important for the factor affecting FRC. And the last one, relative fiber matrix stiffness. Here there are 2 types for the for relative matrix stiffness. For fiber matrix stiffness is nothing but the fiber with the concrete later. Okay, so here there are 2 types of the fiber matrix stiffness. One is for low modulus fiber and high modulus fiber. Already I said where we go to get from that your low value for natural fiber only. In the natural fiber, already for natural fiber and synthetic fiber, that strength value will be for less compared with that artificial fiber. So here I would taken for the normalist fiber for synthetic fiber like as nylon fiber and polypropylene fiber. These two all will be for synthetic fiber, and high molasses fiber it will be used from steel, glass and carbon and air glass fiber and basalt fiber, right? These are all will be for artificial fiber. Like artificial fiber is nothing but man-made fiber, right? And these are the four mainly for the factors affecting in fiber reinforced concrete, right? When we go to choosing for any type of the experimental work, first you must be considered for this all the four criteria. After that only you go to start from that experimental work. And the next one, the main difference between fiber reinforced concrete and normal reinforced concrete. So easily for the last 20 slide I explained, easily you understand for when I go to apply for the fiber material. And what about the normal concrete? Easily you go to say that what is the difference between these two. The first one is that first most they given for that life period, that is a durability condition. When we are using for that normal reinforced concrete, that lifespan will be very low, right? When you do same that for you using for fiber reinforced concrete, your durability condition will given for high, that given for long life period. And second one is from the corrosion. Mainly I said for that two type of that reinforcement. That reinforcement you are using for the normal concrete, you are using normal reinforcement, surely it will be affected by the corrosion, right? What are the structure you are using for reinforcement after 10 years or 15 years, what happened? The corrosion will be formed. But when we go from that fiber reinforced concrete, it will be protected from the corrosion, because you go to apply for the coating material and you have to taken from some high strength. This one for the high strength is not easily affected for the corrosion also. And another one is from when the normal concrete they having for heavier material, when you are using for the fiber, it will be for very lighter material. And only one the parameter that is at opposite for the normal concrete and fiber reinforced concrete, that is for cost wise, right? When we are using from the normal concrete, you got to go from that only for cement and fine and coarse aggregate. But when you come from that fiber reinforced, depends upon that artificial fiber, they having different fiber is there. Already I said different type of the fiber, that based on the strength wise the rate also different, right? When you go from the carbon fiber, the rate that it will be calculated for 1 meter cube, it will be around something from 2500 or 3000 it will become. But when you go from that glass fiber, that value will become for 2000 like that, 1800 to 2000. And when you go from the air glass fiber, that value will become for the 1200 to 1500, that rate will become. Is this value I said for only 1 meter cube of concrete only, right? But it is all fiber, it is available in India also, and you are wherever the near place is there, easily you will get from this type of the fiber. And another one for the main road for the same volume, whenever you are using for the same volume, that value will be for the strength is you will be get from less for normal concrete. When we go from the fiber reinforced, your same volume, you go to use the strength value will be higher, right? And the last one for workability. The workability is the main role, because of what is the purpose you are selecting for the fiber, what type of the fiber. Why? Because we want to improve our workability of concrete, right? When we go from that normal concrete, what happened? That high workability will be taken, right? This will be for the bleeding, it will be happen. So we want to control for that over excess of that water. So you go placing from the fiber reinforced. Whenever they go to using for the fiber reinforced, your workability will be very less. And here I will show some of the parameter for advantages of fiber reinforced concrete. Here I will show from various parameter, right? For strength, durability and other some advantages. For the strength wise, they having for three types I will taken from tensile strength and impact strength and compressive strength. Where you go to using for the tensile strength, when that building they having for more than some value, load will be acting in the future. So what happened? Your normal concrete will be go for the, surely it will go for the failure. But at the same time, if you are using for the fiber reinforced, when the load will be in the future, the load will be increased, but your structure will not go for the collapse. In the crack also, it is not possible when the fiber will be acting. At the same time, for the impact strength means I said for the blast or some from suddenly applied load, I said in this type of the loading also, your strength will not be differ, because of we are using as a fiber reinforced. As well as for the compressive strength, right? When you go to taken from that compressive strength, already I said when concrete they having for strong in compression but weak in the tension side, but when we go from the fiber reinforced concrete, both it will be given for more strength, right? And another one is from the durability. So the durability for I said from the long life, like that, how it will be happen? Three parameter is there. One is from the crack, right? If the crack will be formed, your structure will be failure. It is not given for more life. When that water leakage will be happen, so the structure will be taken for that water leakage, surely the structure will be failure. And another one from the fire resistant. Suddenly the fire will be formed, your structure will be get the damage. These three all resist when the fiber reinforced concrete will be used, right? That is a purpose for the durability condition is 3 I given. And another some advantages are there, that is from when you are using for that fiber reinforced concrete, they having for lower maintenance, no need of for monthly and yearly, no need. Because of you are using the fiber, there is no any problem, crack formation also it is not happen for within the 5 years, like that, no need of maintenance. But in the normal concrete, so many maintenance is there, weekly maintenance, monthly maintenance and yearly maintenance is there, okay. But when you go from the fiber reinforced concrete, no need. And next one from the shrinkage also, already I tell them for some properties. In the properties they having from plastic shrinkage and dry shrinkage also they go to reduce. At the same time from the permeability, wherever the water structure is there, that leakage, it will be reduced for the permeability also. And the load carrying capacity, right? When the load will be higher, the structure will be resist, because of the structure is made up of fiber reinforced structure, right? And here up to 22 slide I will explain for all the parameters, some of that outline, and what is the advantages and what are the fibers I explain. Now for easily understand purpose, I go to taken for the some case study, right? So here all of you see this one, one case study I will taken from that experimental rated program. I go to using for one beam structure, one real beam structure. So the length will be taken for 2.2 meter, right? The length of the beam will be taken from 2.2 meter. When in our classroom, you just to see that for the beam, surely it will be for more than 2 meter is there, right? So that type of the real structure beam for the we go to connect for the test. How we go to connect from this one? In the top reinforcement, you go to using from 2 numbers of 12 mm diameter of the bar, and bottom beam 2 numbers of 12 mm bar. It will be connected by the stirrups. They having from now numbers of 2-legged stirrups 8 mm. The stirrups has size having for 8 mm at 200 mm center by center. These 2 stirrups, the center will be taken for 200 mm. Totally how many stirrups we will consider? For 11 numbers of stirrups I will consider. And top reinforcement and bottom reinforcement, the size will be taken from 12 mm thickness, right? Here the loading setup, how the beam will be resting on the support. Here I got it taken from the 2 type of this support. One is from hinged support, another one is from fixed support, right? And here in that above I go to make it as that one small plate. Why I want to make it as that one small plate? Because your load will be equally distributed into 2 sides, right? That is the purpose I go to kept it for that beam above in the support. Here the length will be for 200. For the span length will be taken from 1800 mm. How we are going to taken from this one? For listen here, from the support to center of the portion, that value will be taken from 600 mm. In the 2 distance for the beam, in the middle portion, that length will be taken from 600 mm. And the third one is from another support, like as a hinged support to your 600 mm, like as a L third of the distance. L third of the distance. Then only your load will be equally distributed from the two support. That purpose only I given for this type of the structure. And why is the support I given for? One is from here hinged support, another one is from fixed support, because then only the structure will be for statically determinate structure. Clear? Because of your fixed support and hinged support, how many reaction that will be resist for in your fixed they having for the 3, and from that your hinged support will be 2. If you go from that any 2 hinged means surely your structure will be go for the 2, but equilibrium equation will be go for the 3. So the structure will be go for easily failure. So that type of the support we don't go from anywhere in the experimental work. That the purpose only I go to given for. One is fixed support, another one is from the roller support. How it will be placed here. Now I want to make it for that beam, for beam test by using the fiber material. Already I said, for fiber, not only for the reinforcement, it will be acting for external strengthening of the structure. So here how I go to placing of this fiber into the beam. After that, how we go to conduct for the test. First of all, what I go to do, in that bottom side of the beam, here this is the bottom side, this is that for the 2 side, right? The 2 side, first I want to make it from chipping, right? The surface will be from the rough condition, not for the smooth. If you are making it as the smooth, then fiber and concrete both it not will be bonding, right? That is the purpose. What I am going to do, I want to make it as the chipping from all the side, and after that I using for the air blower, and I remove all the dust in the inside of the gap, right? Because I go to using for the chipping, surely inside the dust will be available. So I want to remove that all the dust by using the air blower. After that I go to using for that resin material, right? So what is the meaning of this resin material? What is the role for that resin in that structure? Okay, this is nothing but very simple thing, like a gum material. If the 2 material will be joined, how it will be joined? Some gum material only, that both it will be joined. So that type only you are using for that. I go choosing from that resin material, epoxy resin. Okay, how we go to mixing of this epoxy resin? Not only for that your resin material, it will be added for hardener also. If the both will be mixed only, it will be go for setting, right? How from how much quantity it will be taken? When you go to go from the resin material, 1 liter of that epoxy resin plus 5 ml of that accelerator, that the hardener you should include, right? This is the ratio for mixing of the resin and hardener material. So here I go to taken from both, it will be for mixing, and after that I go to apply by using the brush. Wherever I go to make it as the chipping, in that place I go to applying for this resin material. Okay, once apply from the resin material, then immediately don't wait for 1 day or 2 days. Immediately you go to wrapping for the fiber, right? Immediately you go for wrapping of the fiber. So here I will go for some example for glass fiber. In the glass fiber there are 2 types of the fiber is available for the mat formation, for chopped strand mat fiber. Another one is from woven drawing mat fiber. These are the 2 types that will be used for wrapping. Carbon fiber also mat is available, alkali resistant glass also available, but when you go from the cost wise and we have some limiter strength value, so better we go from that glass fiber, because it is easily available material and costs also somewhat economical, but the strength also they given from good. So I go to choosing from the 2 type of the fiber. After applying for the coating, immediately you go to placing of the covering of the 3 side, bottom side and both side also you go to wrapping for this type of the fiber. And here before I go for the testing, what I have to do, I want to make it for the tensile strength of the, I have to find out for Young's smallest value. Here why I want to go for separate test, I go to conduct from for tensile strength value, because of I show that one tabular column that is for Young's smallest value and aspect ratio value, then elongation value. I will show in the density value. All values are in experimental. Separate values is there, elastic value, everything is there. All type of the fiber values there. But here what I go to choosing from this one, For one layer I go to placing for chopped mat. After that again I go to apply for the resin. Then immediately I will move on to the next fiber, that is for before that I go from the woven drawing method. Two material I will go for strengthening of the beam structure. Chopped stand mat, another one is from woven drawing mat. Two mat I go to applying from the beam. So the first one I go to apply for chopped stand, then apply for resin. Again I will move on to woven drawing. So two fiber will be added. So that type of the test they don't given in the tabular column, they don't mention any your Young's smallest value. That purpose I go to calculate for that tensile strength value by using for ASTM method. I will calculate for this type of the shape. In the top and bottom side I go to make it from one handle section. Why I go to make it for this two for handle? Then only it will be placing of the tensile testing machine. In the tensile testing machine, in the top that will be attached and bottom also it will be going to the attached. That purpose for the crimping it will be formed, right? The crimping it is needed. That purpose only I will make it for the top as well as in the bottom. I want to make it for one bigger size for the handle portion, and centrally I will make it for this one for CS4 and CS and WRM, like for chopped stand mat, woven drawing mat, either one layer or two layer, like that, and combination of both one layer or two layer. So different 8 type of that fiber I go to conduct for the test. And one more thing I go to using from deformation. Okay, because in the tensile strength load you go to apply, and where we go to get from the deformation value? By using for strain gauge. Okay, here I go to make it for placing of the strain gauge in the middle. So easily in the strain indicator for digital value you will get from the deformation value for the strain value, right? Stress value is known for that area, and load we go to given for 2 kilonewton, 4 kilonewton. For cyclic loading you give. At the same time strain value you will get from the strain parameter by using for strain gauge. Okay, for one piece of the strain gauge for 50 rupees only. So we go to taken for the find out for strain value. Easily you go to buy for the electrical strain gauge. And here, so this is for the tensile strength machine, and here the load indicator is there. When the load will be adding for the cyclic loading, here the top portion and bottom portion both are that will be for the crimping, and here the center portion for strain gauge. So the strain gauge it will be go on from that load indicator you go to taken for find out from the strain value, right? This is for that 4-phase diagram, and 8-phase diagram also is there. So you have to easily identify for that value for what are that various load is there, and when the roll will be failure. Here in the tabular column I got from some of the value for ultimate load and stress value and Young's smallest value. The first specimen for CS1 chopped stand mat and WRM woven drawing mat, and the third one is for combination of chopped stand mat and woven drawing mat, and what type of the load we will get. If that for single one only one chopped stand mat you get that ultimate load of 650. When we go for that WRM, that maximum load will be taken from 1625. When combination of these two, that value will be taken from 2350 Newton per mm square. And the stress value, you know that load, and area you know, then easily you go to calculate for the stress value load by area, and the Young's smallest value stress by your strain value is there. For a strain indicator easily get for the strain value, then you go to calculate for the Young's smallest value in Newton per mm square. So the maximum Young's smallest value will be getting from the combination of the two fiber for chopped stand mat and woven drawing mat. That is the maximum value for combination. Okay, and this is for that. After I will find out for tensile strength for that only fiber only I conduct for the test. Then now I come for again that beam structure here. For this is for that two support. Here the two support is that, and one is for the fixed support, another one is for the hinged support. In that above you go to placing of the beam, and above you go to placing from one I section for a channel. One I channel section I go to given from here, right? One I beam section. So the purpose of I beam section, because of without you go to using from this I type of the section means what happened, your load cell it will be settle on in the beam. It is not possible, right? So to avoid that one, how the load will be acting, we go to the load cell will be placing above in the steel. in the below beam section for 2 roller section I given. What the purpose of this 2 roller? Because of here in that roller, for roller 2 your support that distance will be L3 distance, and the 2 roller the distance also L3 distance, and that another roller support to the hinged support L3 distance. Here the load will be for acting at center, easily distributed in both the side. For what happened, W roll will be acting at center, half of the load will be transferred to one support, another half of the load will be transferred to another one support. So where you go to find out for the deformation value. Okay, when you go to draw for that stress strain diagram or load versus deflection diagram, how deflection will be happen in the structure. When the load will be acting, surely the structure will go for deflection or deformation. How we go to find out from this one? Here I go to using for 3 place, I go to placing from the dial gauge, right? In the dial gauge only you go to find out for the deformation, where I kept one is from one roller, another one is from maximum that deformation will be taken from the center, another one is you kept it from the right side of the roller below. Then only you go to find out for the 3 place, you go to find out for the deformation value, and the load will be acting at the center. So this is the load setup. The maximum load it will be taken for that 50 ton loading setup. They go to using for the real beam structure, right? This is used from the structural engineering laboratory. Okay, so all the strain value you go to find out for here. The load, this is a load indicator, indicator cell is there. So wherever the load will be given, this is the load cell. So that I go to apply for the load 2 kilonewton, 4 kilonewton, 6 kilonewton, cyclic load only I will give, constant load, right? Then that load will be indicated here, and you go to make it for the strain value also. Because of here I go to using for 2 place, I go to placing from the strain gauge. One is from your top as well as bottom. Where I get from the top and bottom, we must be known. In the previous diagram I will show you for section diagram. For the beam section diagram already I explained for the top reinforcement and bottom reinforcement, where it is located from that bottom to 25 mm clear cover, and from the stirrups. After that you go to placing for that for your reinforcement. So you know the where is the distance will be there. So according to that I go to placing for the 2 strain cages, right? In the top reinforcement place and bottom reinforcement place I placing for the 2 strain gauge, and it will be connected from your load cell indicator. Then easily you go to find out for the strain value in reinforcement. How the reinforcement go for the deformation, that strain also you go to find out from that your indicator value. And here see in the diagram for this is one from after failure of the structure. Here all failure will be taken from the flexural failure. Our aim, the structure will be go for the flexural failure only, right? Please all of you see this one. The crack will be come for the some minimum dimension only, not for the bigger one, minimum size only. Without fiber, so what happened when the load will be acting, surely the structure will be go for the crushing. But here when fiber will be acting in the structure, so what happened, this is the control beam. Please note it down. This is for control beam only, and this is one is from the failure pattern, and these are the for 2 strain cages. That purpose only I will show this diagram. Okay, and here what are the parameters you go to find out for after conducting for this experiment for load versus deflection diagram and moment and curvature diagram, and from load versus strain diagram and load and stiffness diagram. The stiffness is nothing but that is for W, that is load divided by your deformation, that is called for the stiffness value. Because of in concrete you are using in the fiber reinforced, they given for more stiffness, right? If they not go for easily breakable, it will give more strength, more stiffness value, more strong. That is the purpose only. In the graph you go to check, right? For all type of that your graph you go to taken from after completing of this experiment value. And the next another one case study for here beam previous case study I will discuss about that beam structure, and second one I will move on to that column, right? This is one for the column. They go to using for different steel fiber and polypropylene fiber. For previous one, I go to select for the glass fiber for two type of the mat, for chopped and woven mat. But here the second study for the concrete column strength and improved for steel fiber and polypropylene fiber, and what ratio they go to adapted, and in which fiber they are given that more strength, and how that column will be placed in the loading setup. See the column in the vertical position here, they have to taken for the two types of variety of columns. One is for the spacing, depends upon the phase spacing they are selecting from this one. Column with ties spacing of 100 mm. Another one is from the closing for column with ties spacing of 50 mm. Two types of the case study they go to select that for column member. Here this is the load setup for the beam. Now we move on to that for column structure. For here the column is a vertical member, so the dial gauges will be placed from that here in this position. Why? Because in that vertical for column, so it will be for the deformation will be taken from your curvature, like the curvature buckling failure only it will be formed. So you go to placing from the dial gauge in this position, and second one for the column, and third one from the load cell we go to taken from the bottom side. In this diagram, this is for that load cell, the bottom only it will be go for the load cell, and that output device they go to taken from where the load will be acting, how much load will be acting, and the dial gauge reading for the deformation value you go to calculate by using. This is the load setup for column. And what is that result they are getting from this one? For additional for steel fiber, the volume fraction will be 0.7%, and aspect ratio is given as 100. Okay, for aspect ratio here they are using for 100. This is the given for more strength related for compressive and splitter and flexural strength, and given for that maximum modulus of elasticity value. Right, these are the for case study 2. And now we move on to the third one for applications of FRC. Right, previously I said advantages and fibers related and case study. Now I move on to for application, because my main title for that application where the fiber is used. Here I given some of the fiber used in the construction. First one is for fiber reinforced used in the residential construction. For residential construction, where it is used for foundation level and wall as well as for the roof level, they go to using for this fiber material. Why? In the foundation also they go to using from the reinforcement, also they are using for that fiber material. Why? Because all the load will be distributed into the ground only, so this will be taken for load carrying capacity, it will be more. So to avoid that maximum load, you go to placing for the foundation level. At the same time, for the walls also you go to using for the fiber reinforced concrete, and the roof also they go to cover from that fiber reinforced concrete. And commercial building, what type of the structure they are used for the fiber reinforced parking structure and industrial slab also. And another one, infrastructure project also. I said from the fiber is not only used for the building, it will be using for the pavement also. For road pavement also the fiber will be acting. At the same time for the airport, for the runway also that will be made up of that fiber reinforced concrete, because the creep will be formed, right? And last one is for the bridges and tunnels also, because in the bridges maximum load carry capacity will be more in the bridge structure. So in the deck it is made up of for your fiber reinforced concrete and tunnel lining and the retaining wall, mainly for the retaining wall. So what is the purpose of the retaining wall? It will be for suddenly you go to resist for that horizontal load, right? For the soil it will be moving in the horizontal. To avoid that one, you got to make it for construction of retaining wall structure also. So these are the types of application for fiber reinforced concrete. I will show some few diagram only for where that applications of fiber is used. For the first one, for in this structure it is available in that hospital building in Dubai. Recently it will be constructed. For this all from the cladding for using as fiber cement. This all that will be cladding, everything that will be using for fiber cement only. At the same time for that wall it will be making for cement fiber wall cladding also. And from that I said from the retaining wall, that is from that your side wall, to avoid from horizontal load like soil. So to avoid that one, I go to placing of that the reinforcement with the fiber reinforcement, I go to placing in the horizontal as well as in the vertical direction to avoid that all the horizontal load. At the same time in the ground side also, when that your floor level also you go to using for, instead of our normal reinforcement, you go to using as a fiber reinforced also. And another one, when we go from that your water tank, any tank related, some underground structure also they go to using for fiber later reinforcement also. At the same time for the road pavement, already I said in the previous slide, for the road pavement also you go to replacing of fiber reinforced only, right? This is for the second diagram. And another one is from when the roof level also, instead of our normal reinforcement, you go to placing of your fiber reinforced. At the same time for water leakage, like water tank, when we go from the water tank or sewer water treatment plant, that one also you go to placing of your fiber reinforced, because of it will resist that water leakage. That purpose you are using as fiber reinforced. These are the some of the diagram it will show for the structure later where the fiber is used. Okay, and for actually 1 hour I given for only 5 minutes break. Then I will move on to the last some 5-6 slide. Then I go to end of our presentation. Okay, thank you. I will move on. Next 5 minutes I will come back. Okay. Now I start from continuation of my presentation. Here some of the literature review. Already I told the literature review. Whenever the presentation is there, the literature review will come from second or third slide. But here I given as the last one. Why? Because of before we go from that the literature review, first of all everyone must be known what is a fiber and what is that role of fiber and what are the various factors they are affecting and what is the advantages, application. Then now if you see this one for the literature review, so many researches they are done for different type of the fibers they are using. Okay, but I will select only the few literature review, what they have to connect that experimental result value and what type of the fibers they are using and what result they will get in their experimental work. Oh, here I will see some of the literature review. First one is for mechanical properties of fiber reinforced concrete. So they are published in the Journal of Construction and Building Material. And what type of the fiber they are using? Steel and polypropylene fiber and etc. Some more fiber also they are using. And finally they have to find out for the mechanical properties. That mechanical properties is nothing but that is for the composite strength and split tensile strength and flexural strength, right? This three type is mainly for the mechanical properties. Other than that mechanical properties also maybe they will identify, right? And finally they will get from strength as well as the crack resistant. That our main aim, actually that main aim to avoid the crack. So this person for Sarindra Kumar, Pradeep Kumar, they were to using for two type of the fiber and they identify what mechanical properties and what are the parameters they are studied. And the second one for performance of hybrid fiber reinforced concrete. The hybrid fiber, the name the hybrid fiber is nothing but when that fiber is more than one fiber, like a steel combination with carbon or carbon combination with the glass, polyester combination with polypropylene. So that the material having for more than one, then the fiber is called as the hybrid fiber. So what are the results they are getting? The combination of different type of the fiber and they mainly they will calculate for the mechanical properties as well as for the crack control parameter also. And third one is for the durability of fiber reinforced concrete, and here they will be for the durability means the long life. Already in the 7th slide I explained for the durability condition. What is the durability condition? You got to identify for the three parameter. One is from your chemical attack and freezer cycle and abrasion. These three they are studying for this type of from durability fiber reinforced concrete, and they will be for identify what are the failures that will be happen. And next one is for recent development in self compacting fiber reinforced concrete. And another one more time is there. This for the NG and show they will be using for self compacting concrete also. They go to using for fiber reinforced fiber materials, right? Finally they will taken from what are the mechanical properties and workability, because the workability is the main role for all the type of the testing. So they will be using for self-combating concrete with addition of some fibers. And next one for effect of fibers on the fresh and hardened concrete. In the fresh concrete, you must be know very well what is that fresh concrete and what is the hardened concrete. In the fresh concrete, they are having for slump or compaction factor or flow test, that is under some fresh concrete. When we move on to the hardened concrete, maybe they will be for cube and cylinder as well as for flexural beam, and what for that result they will be taken from both. Mainly for the fresh concrete, you go to identify for workability of concrete, and you go from the hardened concrete, you go to find out for the strength parameter. So they go to study for the fifth one. And another one from that impact of recycle, for recycled fibers also they are using. What are the recycled fibers are there? That is for your nylon or steel and plastic. These all are for recycled fiber. That one also they are connected for the test. And fire resistance,